Hello and good day to everyone. My name is Nirajan Mohara from DC10 and I'm going to present you a brief report on hill climbing algorithm. The agendas we will be covering in these presentations are general overview, state space diagram, problem definition, history of algorithm, pseudocode of algorithm, mathematical time complexity analysis, applications, and lastly the limitations. Now moving on to the next slide, we have the introductory part. In the world of artificial intelligence and machine learning, we need to find the optimal solution of complex algorithm. In the field of AI, Hill Cipher algorithm is also one of optimization algorithm. Hill climbing algorithm is a local search algorithm which continuously move in the direction of increasing value to find the optimal solution, which is the peak of the mountain. The algorithm terminates if it reaches peak where there is no other neighbor with higher values. This algorithm is also known as greedy local search algorithm because it only looks for the immediate best neighbor value but not beyond or after that. This algorithm is mostly used if the nodes have the good heuristic value. This algorithm has feature of no backtracking, so we don't have to worry about how to handle the search tree as it only keeps a single current state. Moving on to the next slide, we have uh, features of hill climbing algorithm like generate and test. These are the features. Greedy approach. Yeah, we have talked about this feature in previous slide. No backtracking. We also have talked about these types. We have three types of algorithms, hill cipher algorithms: simple hill climbing, steepest ascent hill climbing, stochastic hill climbing. Now we are here in the state space diagram. This diagram has the local maxima, plateau, ridge. Uh, here is the here is the here is the current. Here is the current state. These are the soldiers. And talking about these important points, local maxima has all neighboring state worst value than the current state. Plateau, all neighbor state have equal value. Ridge, it is the region where the higher neighbors as a slope are present, and the current state, the state of region where we are currently. Soldier, it is a plateau with an uphill edge. Talking about the next slide, we have the problem definition. These problem definitions are the sectors or the different modes where we have successfully used the hill climbing algorithm used to solve usually computationally hard problems and usually used in inductive learning methods. And moving on to the next slide, we have the history section. Johnson and Jacobson gave a joint view of many hill climbing algorithms by defining states on accepting a move from one conformation to another conformation. Now, now going on to the pseudocode. Yes, pseudocode slide. We have step-by-step solution defining. Step-by-step solution defining. Step 1, evaluate the initial state. Step 2, if initial state is goal state, then return success and stop. Step 3, loop until a solution is found or there is no new operator left to apply. Step 4, select and apply an operator to the current state. 5, check new state. Step 6, if you check new step 5 with the sub step, it is the goal state, then the current state, then assigns new state as a current state. Else, if it is better than the current state, then assigns new state as a current state. Else, if not better than the current state, then returns to step number 2. And here if finally it exists. Now talking about the next slide, we have complexity analysis. Complexity analysis, the worst case, best case, and the average case are. This algorithm does not suffer from the space related issue because it only saves the current state or current data. In most of the random restart hill climbing cipher or algorithm, optimal solution is obtained in polynomial time. Yes, some NP complete problem, NP related complete problem computational time is exponential based on the number of local maxima. Now, talking about the next slide, we have the application area. The application area of hill climbing algorithm is very broad. Hill climbing algorithm solves popular problems like network flow, traveling salesman problem, 8 queens problem, integrated circuit designs, and many more. Hill cipher algorithm is mostly used on robotics, which helps their system to work as a whole and maintains coordinates. Next, this algorithm is also helpful in team management in many marketing homes where hill climbing search algorithm can be used to find the optimal solution, such as traveling time of salesperson per day can be optimized by this algorithm. Now talking about the next slide, we have limitations of hill cipher algorithm. Local maxima. In the local maxima, a local maximum is a peak state, but there is another global maximum than local maximum which is more higher. This is the picture where now you can see for this hill, this is the optimum state, but after certain distance there is another big hill. You can see another big. This is the limitation. It is only for local search algorithm. It cannot solve the global. It does not know the global maximum. Now another limitation is plateau. In the plateau, after current state, all further states have the same value in the flat area. You can see this have the uh, flat state where every step has the same value. Thus, algorithm cannot find any forward directions to move. Next is the third one, and the last is ridges. And the ridges are the special form in which it has the area higher than the neighbor area, but as a slope it cannot reach in the solo move. You can see it has the slope. Its slope is higher than but cannot move because it have only the solo move. And moving on to the final slide, we have the conclusion. Here we conclude this hill cipher algorithm is less used in complex algorithm because if it reaches local optima and if it finds the best solution, it terminates. It does not remember the previous state, which can lead up to problem. For avoiding such problems, we can use repeated iteration local search to find achieve global optima for complex algorithm by table search or annealing anything, and many more algorithms are there. And finally, here I want to conclude my my presentation by saying thank you.